In the previous video, I demonstrated how to set up the rectangular block in the vise, resting on parallel bars, and demonstrated how to set the digital readout and took the first cut. The digital readout was set so that the distance from cutting edges to the top of the parallel bars is the actual height which is required. I set the digital readout to 49 millimeters and took the first cut. I'm now going to measure that with a digital caliper. The dimension is 48.77 millimeters. I haven't moved the table since I took that cut. So I'm now going to readjust the digital readout by pressing preset, select the Z-axis and type in the actual size which I measured with the digital caliper. Enter. So that should now have made the height exact. When you're squaring a rectangular block, you should always put the side that you just cut and rotate it so that it's up against the back face of the vise. As you can see, I've numbered the sides. So first side, next side I'll be cutting is side 2, then the third side, and then the fourth side. Always remember a deburr in between. So side 1 is now going to go up against the fixed jaw of the machine. Tighten the handle by hand. Take the mallet, a few taps on the handle, and then a few taps on the workpiece to set it down onto the parallel bars, and check to make sure that the parallel bars are tight underneath the block, which they are now. So this is ready to take the second cut. As I've adjusted the digital readout to improve the accuracy, I'm now going to move the table to 49 millimeters, which was the height that I cut previously. I'm then going to take the cut. Firstly, I move the table in the x-axis to the previously set 0 point. It doesn't have to be exact. And then move the y-axis also to the previously set 0 point. Once again, this doesn't have to be exact, as all we're doing is cutting a flat face, and X and Y position is not critical. Now that side 1 and side 2 have been machined to a height of 49 millimeters, we can rotate side 2, the second side which was machined, to the back and put it against the back face and set it down on the parallel bars. On sides 3 and 4, we can set the height to the finished dimension of the workpiece, which is 48 millimeters. So I'm going to raise the table to a height of 48 millimeters. And take a cut on side 3. Having machined the height and width to 48 millimeters, which is the finished dimensions, we can then turn our attention to completing the length. As you can see, the bar was just roughly sawn to an approximate length on the workshop bandsaw, and the ends are rough, and using an engineer's square we can check and see that the end is not square. This means that we cannot use the existing face to set the workpiece. The workpiece needs to be set using an engineer's square placed on the base of the vise with the blade up against the side of the workpiece to square it up to 90 degrees. Because the workpiece vise is perfectly vertical, we don't need to be concerned about the squareness of the block in this direction, but we do need to set the squareness of the block in this direction. So the block should be placed on top of the parallel bars. We're using the same parallel bars as we did in the previous operation. Move the block slightly off centre so that there's space to get the engineer's square in, and it can be seen that the workpiece is not square. What I would then do is tighten the vise very lightly so that the workpiece is just lightly gripped, and then take a mallet and gently tap the workpiece until the side of the workpiece is flat up against the blade of the engineer's square. At that point I would then fully tighten the vise. One final check shows that it needs a slight tap to make it exact. Having squared the workpiece up using the engineer's square and tightened the vise fully, it's now ready to take a cut across the top face, which is the first end of the block. In this part of the operation, you should not tap the workpiece down with the mallet, because if you tap the workpiece down with the mallet, you may alter the squareness of the workpiece. So do not tap it with the mallet in this instance. The digital readout is still set so that it shows the distance between the parallel bars and the cutting edges. Now, having previously measured the length of the workpiece as it is, it measures approximately 80 millimeters. So if I set the height to 79 millimeters and take a cut, it should be taking approximately 1 millimeter of material off this face. So with the height set to 79 millimeters, I'm now going to take a cut across the first end. Having machined the first end, which I've marked end A, we can then move to machining the second end to create the finished drawing length, which is 75mm. The block can be placed in the middle of the vise this time, because we've checked to make sure that the first end, end A, was square in both directions. So it can be placed in the vise tightened, and the workpiece tapped down with a mallet, because we have a flat, square, finished end at the bottom. The height of the workpiece to the unfinished face is 79mm. The finished height is going to be 75mm. 4mm is too heavy of a cut to take off in one go on this type of machine with this type of cutter. So I'm going to take 3 cuts, one at a height of 77, another one at a height of 75.5, and a final finishing cut at a height of 75. Having now completed the overall dimensions of the block, 48mm width, 48mm height and 75mm length, as can be seen, it's the same as the sample. And in the next videos we're going to move on to show how to create the various types of slot and step features. The length of the piece at the moment is 79mm, so there's approximately 4mm to be removed. With this type of cutter and this type of machine, it can't be removed all in one cut. So I'm going to take one cut of 2mm at 73mm height, and another cut at 71.5, and another